this is chapter 16, question 117. Okay, it's about the trend in physical and chemical properties of halogenal alkanes. They are asking about chloroethane, bromoethane, and iodoethane. Now, which properties will increase from chloroethane until iodoethane? Number one, the polarity of the carbon-halogen bond. A bond is polar when the two atoms, okay, sharing the electrons, they have different negativities. So in these halogenal alkanes, the CX bond, okay, the C and the X have different electronegativities. So we have CCl bond, okay, we have CBr bond, and then Ci bond. So going down a group, any group, okay, electronegativities will decrease because the size of atoms became bigger. Okay, so electronegativity decreases. Therefore, iodine has the lowest electronegativity, followed by bromine. Chlorine has the highest electronegativity. So, the bigger the difference in electronegativities between the two atoms sharing the bond, then the more polar is the bond. Therefore, because Cl is the most electronegative one among all the halogen, CCl bond is the most polar. Ci bond is the least polar. So, okay, I'm going to draw an arrow to show you that from CCl until Ci, okay, polarity decreases. Okay, so number one is not correct. Okay, it's not one of the answer because the properties decreases from CCl to Ci. Let's look at the second one. The boiling point of halogenal alkane. Now, when we talk about boiling point, we need to consider the intermolecular forces. All these halogenal alkanes, they have one polar bond, therefore the molecule is polar. So every molecule here is polar. They have permanent dipole forces. Okay, permanent dipole forces between the molecules. Now, they also have something called van der Waals forces. Since all of them have permanent dipole forces and they are very similar because all of them are polar, so we do not compare their permanent dipole forces strength. We need to compare the strength of the van der Waals forces. Sorry about the wrong spelling. It's supposed to be WAALS. Okay. So from C2H5Cl to C2H5I, okay, the number of electrons increases. Okay. Now, when number of electrons increases, it will lead to the increased strength of van der Waals forces. Okay. So cause the boiling point to increase, because now need more energy to overcome the van der Waals forces between the molecules. Therefore, number 2 is correct. From chloroethane until iodoethane, boiling point increase. Now let's look at the third one. The rate of reaction of the halogenal alkane with nucleophiles. Now, this one, uh, if you want the halogen, okay, the Cl, the Br, the I to leave and replaced by another nucleophile, a new nucleophile, you are breaking the CX bond. So you need to see which one, which CX bond can be broken very easily. Which one is the easiest to be broken? So CCl, CBr, and Ci. Ci is the weakest. Okay, why is it the weakest? Because it is the longest. We're talking about covalent bond, right? You look at the size of the two atoms, then you measure the distance from one nucleus to the other nucleus. The longest one, right, will be the weakest bond. So because iodine is very big, so from the nucleus of C to the nucleus of I, okay, will be the longest. Now CCl is the smallest among Cl, Br, and I, so this is the strongest bond. Hardest to break. This one easiest to break. Okay. Now hardest to break one, the reaction will be slower. Easiest to break one, okay, the reaction will be faster. So from chloroethane until iodoethane, the rate of reaction increases. So number 3 is also correct. So the answer to this question will be C.